Hello everybody. It has been bothering me ever since I did this preview review or view of something of this upcoming Campagnolo 13 speed group set that I told you in that particular video that this 13 speed thing is going to be more or less equivalent when it comes to range and general utility to a double with an 1132 cassette. Unfortunately, I was wrong. It would be equivalent to 11-30 cassette, but that's the minor detail. However, I made a little, application that's going to show me how such a drivetrain is going to operate or how it's going to feel at the shifter, and I have to admit that I was wrong on something else. It's going to be much better than a double, and here's why. Okay then, the graph you've been staring at since the beginning of this video is something you should be familiar if you watched the You Are Overgeared video I posted previously. But, if you don't know, this is a graph of speed over cadence. In the x-axis we have the horizontal axis we have speed in kilometers per hour. On the y-axis, or the vertical axis, we have cadence in rotations per minute. Our experiment here is to compare two drivetrains. The red line shows us the Campagnolo e-car with 33 tooth chainring and 9-36 cassette. And the blue line shows us the prototypical 2x11 52-36 chainrings and 11-30 cassette. And since now we know what this graph represents, what precisely do we see here, or what can we tell about the dynamics or the usage pattern of the drivetrain by looking at it? Well, the vertical line on each plot shows us the moment where a gear change occurs. The algorithm I have used here is one that presumes that you are going to be switching gear to a next gear, which is going to be higher or lower, when on that next gear you are going to be closer to the 80 RPM's cadence than you would be on the previous gear. On Campagnolo e-car we have 12 such changes, and on the prototypical 2x11 we have 15. So what sort of a picture can we take out of this? Let's divide this plot in two distinct ranges, above 28 km per hour and below 28 km per hour. I'm using this particular limit because above approximately 28 to 30 km per hour, aerodynamic drag starts to dominate above any other source of drag so highly that even a minute change in speed means that we are going to be facing much higher drag. Below 28-30 km per hour, it is not as severe. In the range below 28 km per hour, the 2x11 drivetrain will give us 10 distinct ratios to use. In comparison, the Campagnolo e-car is only going to offer us 7. On the other hand, in the range above 28 km per hour, the 2x11 is going to provide us with 5 distinct ratios. However, e-car is going to provide us with 6. And those 6 gears is what makes e-car so great, because above 28 to 30 km per hour we are in the zone which is dominated by aerodynamic drag and its nasty tendency to be dependent on the square of velocity. Once you're in this zone, you want to stay as close to your optimal cadence as possible, because even a minor increase in speeds requires a quite significant increase in power output. You can eyeball how much your cadence is going to change on each gear switch by looking at the height of vertical lines on this plot. And you can see that in the range of speeds above 30 km per hour, where it matters the most, e-car is very consistent and is approximately half of that on the canonical drivetrain. However, in the range of speeds below 28, which is a range that's dominated by gravitational drag, having closely spaced gears isn't as beneficial as in the other end of the spectrum, because the gravitational drag is more or less dependent on the sign of the incline of the road and not a square of velocity, so it's rising or is varying to a lesser degree, so varying cadence is something that you can easily recover from, and riding at lower gears means that you can push more force into your pedals and once again recover from lost cadence. So having closely spaced gears in that particular range means that you will be most of the time double and triple shifting in order to compensate for rapidly changing speed. As you can see from the graph I'm showing to you, you have one speed or one ratio just about every 1 km per hour increase from 13 to 19 km per hour. That's simply too dense. However, not having closely spaced gears when you're riding, and 30 plus means that even a minor change of speed requires you to push a significant amount of effort into your pedals. Essentially, on a road you want to have a drivetrain that is biased towards high speeds and gives you as many high gears as possible, and by high gears I mean as densely packed high gears in the range of 30 to 45, than having lots of gears in the range of 30 to 14 kilometers per hour. Essentially, when you're climbing, you're going to be climbing with force whether you like it or not, and having 50 gears there isn't really beneficial to you. And the surprising result from this comparison is that Campagnolo E-Car is going to provide you with more tightly packed high gears in the range of 30 to 45 kilometers per hour. As a trade-off, you're going to get less gears in the range of 12 to 30 kilometers per hour. However, in the range of lower speeds, having tightly packed gears isn't all that beneficial, at least on the road. So, Campagnolo E-Car 1x13 is better suited for road riding than the current canonical road drivetrains. And this is the result I wanted to share with you, and I hope you like this video, I hope you're going to share it around, and I hope to see you on the next one.